Is Robin. His talk is from small microservices to global hybrid cloud e-commerce platform. This talk will discuss Terraform, the story behind a successful international IoT platform launched on a global scale. He's a technical architect at Mindcurve, whose mantra is to basically automate anything that needs to be done more than once. And he likes developing strategies to use technology beyond their intent. So please have a round of applause for our next speaker, Robin.
Hello. Uh, hello? Yes, now, okay. Yeah, sure. Just do it from the middle. Rahul is just going to take a picture of you guys. Wanted to have something to take with me back to Germany. Now it works. Okay. So, yeah, hi, my name is Robin. Oops. I'm from Germany. I work for Mindcurve in Oberhausen. And we build, design, operate mission-critical infrastructure, as you can see on the slides. That basically means we are more on the management side of things. We don't necessarily do software development per se, although we definitely have the skills and the people to do that. Some of our people are constantly working on implementing small microservices. But our main focus is basically providing the infrastructure and the services for our enterprise customers. And we are not just talking about one platform there. We have actually many different companies we work for. And I'd just like to talk in this talk about one specific example where we basically use Terraform to implement all those things. And to give you a few takeaways that many people probably have not yet thought of doing or have not even tried. Even though we are not a software development company per se, we do infrastructure as code. So in the end, we produce code, and that has damn, it sounds weird. Okay, hello. Okay. That basically means we have to do the same things that every normal product development team has to do, like we have to do continuous integration, we have to do continuous testing, and continuous deployment, of course. And we are basically just here to share some of our experiences, some of our ideas on how to approach things with Terraform. So, a little bit about the background, about the things that we are talking, that I'm going to talk about. The client is a really old company, has been founded in 1882 and is still on the market today. It's still a family business, and they have a wide range of products, and from household appliances to basic items that you can buy for your home, but also services and much, much more stuff. Suffice to say, it is a really big company, and what they are doing is basically they constantly invest in the future. They have a product that is now in its 9th generation. It has been introduced to the world in 1961. And now this product suddenly is an IoT device, so it speaks with the internet. And of course, it needs a site to talk to. It needs services to talk to. And this is pretty much where we come in, and we have to build that infrastructure. We had to build the concepts, we had to build the containers, we had to build everything, the tooling, everything around needed to run that platform. And we've been given quite a few really high requirements from the customer. First and foremost, it needed to be a hybrid cloud architecture because they already ran a data center and they already have been running that for many, many years. And suddenly now there's a thing that is called cloud, and they want to use that as well. So we needed to migrate their existing infrastructure to that cloud environment. So it's not only setting up a new product or a new thing, no, it's actually evolving the old thing to the new world, to the new stack. Um, we defined a few basic rules, how to go about that. And the first and foremost point for us was we wanted to have a provider agnostic approach. That basically means we don't want to be married to the service provider that we are using. We don't want to be tied to one specific provider. If the requirements from the customer side changes and the customer says, okay, in this or that country, AWS is not available and we want to use Google Cloud, or we want to use another data center, or whatever is available, we need to be able to do this with this approach. So just going for CloudFormation and using that wasn't an option from the very beginning, especially because they already had the data centers and they still wanted to continue to use those data centers. And of course, they want to use the same principles. So, of course, the most important principles to do that is the KISS and the DRY principle. KISS in the sense of keep it small and simple. You could also do it, keep it small and stupid, or simple and stupid. But the thing is, we believe in doing things in the most basic, most simple way possible. So eliminate everything that you don't really need and make the things just work on a really basic level that you don't have to mess around with many moving parts. So wherever you look at some problem or another, or service or another, you should never have more than one or maybe two tools in a hand. It should not be like, I need this tool to build a thing, that tool to deploy a thing, and that tool to build infrastructure, and another tool to test the thing. We wanted to do everything in a really simple way where we basically just have one tool in our hand. But we didn't want to develop that. So the other requirements, of course, full versioning for all components, and of course, complete automation. I mean, if you have to do a thing more than once, there is no need or there is no good reason to not automate it from the very beginning. So, yeah, how we built IT. I mean, in the end, we built IT infrastructure, and that is basically our starting point where we go in with Terraform, because Terraform provides us all the important things for building infrastructure, changing infrastructure, and versioning infrastructure. I think I don't really have to say much more about Terraform itself, why it's there and what it can do. I think most of you probably have heard about it. Yesterday there was a really nice talk from a colleague that talked about how they are using Terraform with their product. Our approach is completely different, because in that talk they talked about using other tools as well, like Ansible, but we will get there at the very end. So, yeah, what we are doing with it, of course, managing, creating machines, resources in general, whatever that may be. But we are not only using resources from one specific provider, we are actually using resources from many different providers. So we use, of course, software as a service platforms such as Cloud AMQP, and that stuff needs to be provisioned as well. And the way Terraform works and the way you can extend it using its plugin API, you can very easily extend its functionality, its given provisioners and providers with your own requirements. And I really would like to ask you, have a look at the Terraform code. There are a few examples how to do this stuff yourself. Many people never really look into the code and how this works, but it's really, really simple and it will help you a lot. Then, of course, there are the Docker images. All our Docker images are based on Alpine Linux, just because it's really small and awesome. And in the beginning, we had to work with stuff like CentOS, we had to work with Debian images, and we replaced all of them just for basic Alpine Linux-based images, and we usually got images down from being several hundred megabytes down to just a few megabytes for most of the services. One example, for example, the Jenkins image that is listed in that list, that was based on CentOS, and that thing was about 1.2 gigabytes in size, and we got it down to, I think, 300 megabytes now. And it has all the same functionalities, it has all the same features, so there is, I think the biggest takeaway from that is if you use Alpine, you can get things much, much smaller than you can get it with any other Linux distribution. Our EC2 nodes, and not only our EC2 nodes, they are running vanilla stable CoreOS. It's not modified in any way. We do produce our own AMIs, but always based on that basic image. So our typical provisioning approach is we just run a CoreOS node, we apply all our configuration to it, our service configuration for the Docker images, and then we take a snapshot of that. And that snapshot basically is a new AMI that we then use in the production environment to scale things. Main advantage there is our nodes typically boot in less than a second. So as soon as the instance is started, a second later the services start to start. I mean, you know how it is, some services take a few seconds more to actually boot, but if you have a simple service like, I don't know, Node.js web service or Redis, that stuff usually starts instantly. So if you want to scale things, CoreOS makes it really easy for you to really scale things really quickly. So the main point about this talk is actually the module support of Terraform. It allows you to create components, reusable components, and we are in a somewhat unique position because we not only have one customer, we actually have many customers, and we have many different environments that we need to operate and maintain. And the problem from our perspective is, or the core problem there is, every single environment used to have its own monitoring infrastructure, it used to have its own software stack, and whenever we hired a new guy in our ops team, for example, he not only had to learn one environment, he had to learn many environments. And the Terraform module support is basically going to change all that, because when we now deploy, for example, Elasticsearch, let's say Elasticsearch data nodes, so we have one module that works for every single use that you can imagine with Elasticsearch. Same thing, of course, applies to Logstash, Kibana, Fluentd, Redis, whatever you can think of. Basically, all the images that we have displayed here, it works for all of them. So it is a really basic approach. So just as an example, in this talk, I'm going to use Consul, because Consul is a bit more specific in its requirements, because as you probably know, if you want to run a Consul cluster, you need Raft, and you need to have exactly 3, 5, or 7 nodes to get a Consul cluster up and running and have a consistent quorum. So we built a simple Consul module that, of course, needs to be started at some point, and our starting point is usually the cloud init script for CoreOS, which is represented by this single simple script. It's usually 3 files. We have 1 file for variables, 1 for the templates, and 1 for the outputs. And other modules have even more files in there. But this is just the most basic example. And as you can see in this example, it basically uses a template that is called cloud config sh. So even though CoreOS provides its own cloud config and cloud init mechanism using YAML files, which is probably what you have seen already, we ditched that away and choose a simple shell script, because that is something all our ops guys know from the heart. They know how to write shell script code, and if the requirements should ever change, it is actually really easy to manage and maintain. But let's have a look at that script. We get there. This is the basic shell script template that is used for all our services. And not only our infrastructure services, also the product services, so the components. And as you can see, it's really short and simple. There's almost nothing in there. The most important line is actually line 8, because what Terraform provides here, and what many people of you know, for example, from Ansible, it has a full-feature template system inside. And where Ansible uses Jinja, and you can even extend it and add your own functionalities, Terraform pretty much does the same thing, and it exposes data sources. It has all kind of template support, so inline template. You can have multi-part cloud init templates if you want to go that route. Like I said, we chose not to just because of the simplicity. And it has and a very extendable interpolation syntax for whatever you can think of. So it provides already a ton of functions to do network math, for example. If you want to automatically generate virtual private clouds, for example, you need to specify the IP addresses, and you need to segment your network stacks into subsegments. And you can do that directly using the built-in functionalities that are provided by Terraform. So you don't even need an extra tool or an extra script. And if there is actually something that you are missing, or you have a special use case where you need a special functionality, look at the examples in Terraform. Implementing that stuff is really easy, and you learn Go, by the way. You just look at the code, and you have working examples that you just need to modify. So it's a really good entry point into the Go software development, if you so choose. The module itself for the cloud configuration is, again, something really simple, and you can see this is pretty much the point where we use these templates. So we have, in the install script section, we have all the console-specific install scripts. So these are automatically rendered, put in place, and you can actually extend those as much as you like. And I'm having an example here where you can actually see the stuff that is being executed just for console. Always remember, this is all in the context of just the console module. However, if you copy-paste this and you change just the few lines that you need, I mean, if you want to run Redis, you probably don't need most of the lines. The only things that you probably need is a Redis service configuration and maybe an environment file to have automatic environment configuration for your containers. And you can do that, and it's really, really easy. I'm just using inline templates here, for example. You can even use a script to generate that stuff, if you like. However, we always went in a way, keep it as simple as possible. Here we have one file, everybody can see it, everybody understands, and everybody can work with. So this console module that I was talking about also provides the Docker file to actually build the console Docker image. And it includes the service configuration and a few additional scripts that we already have seen in here. So, for example, there's this console auto-join service that basically just uses etcd to discover all the other console server nodes. So we can automatically discover our cluster without having to rely on, let's say, Amazon-specific APIs, like the metadata service that you would use to discover an autoscaling group and the nodes therein. But etcd is already provided in CoreOS, so you don't really need to do that. And like I said, it is really simple. And the same principle we apply to every single service module. So you could do the same approach with Logstash, with your specific web service component, with even MySQL. We did it with Percona MySQL on a pretty big scale for one project. But it works for everything. And the really nice thing about is this, again, is just a module. So we have a module then that builds our Docker images. So we don't even have a Jenkins job running that is building our Docker files, because we just have one single job that triggers the Terraform run. And Terraform will actually discover if the Docker file has changed, just like a make file, and will automatically build that image. However, the Terraform Docker support is not really up to what you would want at the moment. So it cannot build images itself right now. It cannot use private registries if you want to use them. It is very, very limited. So we basically used a really simple workaround that, in my opinion, is totally valid. Docker provides you a null resource where you can use pretty much all the provisioners that are provided. So there's local exec, so you can run another script. And we basically just created a single, simple make file that is used for all the Docker files in our stack. And we are talking altogether about 80, 90 Docker files at the moment. So 80, 90 different containers that are being built. And this is basically integrated directly through this null resource into Terraform, and Terraform actually understands if this resource has changed, if it needs to deploy a Docker image. Although we really made it simple, we just do all that stuff in the Makefile, and we just basically just give it the information what Docker image is going to be built in this example registry local console, and it will then determine automatically, okay, in the console directory there has to be a Docker file, and there has to be a version, app version variable called 070, and then it knows how to build that file and how to deploy that file in the end. We also have support for one really important aspect. We have a feature that basically checks to which environment you are going to deploy. So if you have a local development environment, just let's say you have this Terraform script running on your local VirtualBox or on a local Docker on your Mac, it will not automatically deploy that image that you just built into some registry. So you can actually do proper local testing. You can actually run the complete stack, all the other modules, and build and test all the images locally. As a side effect, I haven't mentioned this in this presentation. We are using Kitchen CI to do our test automation for our Docker images, not only for the Docker images, but also for the build infrastructure. So that is integrated into this as well. This is an example for the service configuration. So, of course, console needs to be run at some point, and since we are using CoreOS and CoreOS provides us with systemd, we basically use for pretty much all of our virtual machines basic service files to configure them. And if we have a static service like console that doesn't change, that doesn't really scale at runtime, because you always will just have 3, 5, 7 nodes in your production environment or development environment, it is actually much easier to do it that way, but of course you can do it other ways as well, but I'm going to talk about this in a few minutes. Anyway, the really important point about this is you can cascade your templates. So in this example, we have our basic service template, file template, that is basically just a simple service configuration, as you know them from systemd anyway, and there's a placeholder in that service file that is called Docker image. And this thing is automatically filled with the value from the module Docker, as a console Docker image, and it uses the ID of that module. So it has in the service file actually our latest stable image that we want to use. And since this is all configurable per environment, so you can actually have one environment that is running maybe an old console running 065, 062 or 063, and you can have another environment that is running 070. The same thing, of course, works with any other service. So what we did, obviously, we put this thing in a module again. So we can reuse this stuff as often as we like, and we can reuse it with other components as well. I mean, if the template is different and it has different placeholders, obviously you have to create a separate module for that. But then again, if you have, for example, different Elasticsearch setups or different Logstash setups or whatever service you can think of, you basically need one module, and you can have as many configurations, as many templates as you like, and you have a standardized approach that you rarely need to modify. We implemented this once, and haven't it changed since its initial deployment in the development environment, from which it got what is the word? It got promoted to the staging environment, and from the staging environment to our various production environments. So this is just another example. CoreOS provides us with a few variables that we can use in all of our Docker containers. So we typically have our service files configured to read an environment file, --n file, which just holds these basic environment variables, which tells every service, okay, there is my console cluster, this is the private IP address of the node, and the environment in which we are running, the data center in which we are running, and even the region in which we are deployed. So this can be reused for, like I said, for whatever service you like, and this is just a different example. This is a VPC module, and the really nice thing about this is, if we are talking about generic resources like AWS, like Google Container Engine, like whatever you can think of, even DigitalOcean. That stuff has been implemented already. There's a repository available on GitHub. It's the Terraform community modules. And that will provide you with lots of ready-made modules. Some of them are of really good quality, some of them are of really bad quality. You always have to look at this from your own perspective, whether that stuff is useful to you. However, one thing that you can do that we didn't do in this slide, you can actually use the GitHub address or Bitbucket or whatever you use as a source. So you can actually reference the definitive repository in which the module is stored. However, we didn't go that way, and we have a few good reasons why we didn't do that, but I will come to that in a few minutes. The major point about this is you don't need to implement those modules. They are there. Just use them. And we are not using them for the VPC. We are using them for the autoscaling groups as well. And as you can see, autoscaling groups are a bit more complex. You can configure lots more stuff there. But the really nice thing is most of the variables can be just generated from your environment if you just think about the things that you need. And this is just an example. So you can see we have a configuration in our profiles for the console cluster size. So if you want to change it from 3 to 5, it's basically just a variable in the profile that we need to change. And the profile is basically just a key value file. Look for Terraform TF-vars, basically. Anyway, this is just an example. This autoscaling group represents pretty much everything else that you can build. So it could be Elastic Load Balancer, it could be an application load balancer, which basically is just supported for a few days in CloudFormation, even though the service is available for, I think, a couple of months now. With Terraform, you could do that from the very first day, because in the end, look at Terraform. It uses the same APIs that are provided. So this approach will work for whatever resource you can think of. If you have a cloud provider or you have a provider resource supported by Terraform or you implemented your own, you can use that same approach, and it makes stuff really simple. So if we have another autoscaling group, we don't really write this stuff again, because even this is just a module. Here in this example, console AWS module. So we wrap the console service module into a console AWS module. And similar to that, of course, we have a Google module. So there's a console GCE module, which basically uses the same generic console module that provides our service. And we don't have to change one line of code in our console module. Uses the same configuration files, the same logic, nothing specific about that. So, yeah, I already said that. The variables that you saw in this, I mean, there's a variables file, and every single variable in Terraform you can actually override either on the command line, or you can provide it with a file that you can automatically generate if you choose. And the thing is, like I said, this applies to anything. So if you think about whatever thing, think about IAM resources. You want to create and manage your users. Of course, we also have an IAM module that basically does that for us. It creates the credentials, it automatically stores service credentials in our vault, so the credential management is completely automated. We don't have to care about that stuff. You will never find a single spot where credentials bleed into the code base. I mean, there are some points where credentials have to be in the environment of a service, but that is just due to the nature of the service itself and the way how it needs to be configured. But the way Terraform works, you can influence that. So, I already said so. We are using service files for most of our environments because, I mean, yes, you can use big EC2 machines and run several containers on those. And it makes perfect sense if you want to have a small, compact product environment. But for example, for a service like Consul, I prefer just to take 3 T2 micro instances, which cost almost nothing, and I have a proper cluster that has one single purpose, runs in its own VPC, has its own security groups, and everything is completely automatically generated. I don't even need to care about scaling this thing. For me, it's just a configuration variable, And this is actually, I mean, you saw this in the ASG example. The same thing works for any other ASG. So if you have, I don't know, a cluster of Redis nodes and you want to scale that, multi-Redis, same ASG module works. But you don't have to do it this way. You don't have to use service files. If you like, you can use the Amazon ECS agent, run that using such a service file, and then basically just use the ECS provider that is already provided in Terraform and run your containers using ECS. Although personally, again, at the very beginning, we had this point where I said we don't want to be married to the provider. So I would just propose run Nomad. If you haven't worked with Nomad, please do yourself a favor, download it, play with it. It is really awesome. It's the best scheduler available at the moment. And it's really simple. All you need is a really small T2SIM micro instance just to run that. And again, you have achieved the same thing. You have an independent service, you have an independent module, and you are not tied to any specific provider. You can run the same setup on whatever infrastructure as you want. So just to give you an idea, I painted a little picture here. So this actually shows only the service components of one of our environments. And this environment, I mean, as you can see, represented by the 4 AWS clouds, we have this part in the middle. Unfortunately, it's a bit too bright. This part in the middle is actually running in 4 separate regions just for these customers. But we have other customers which are running in many more environments. And everything that is blue in this is pretty much a complete auto-scaling group. It is an own VPC. It has its own security groups, and it's completely automated managed. So there is no need for our ops guys to ever SSH into a machine and do anything there. We have a private cloud environment, which is actually split in two. You cannot really see this, but there's actually a box around these, and that basically separates these environments. And there's only one connection to one specific microservice. So the left side is basically the core shop platform that basically does the order fulfillment, whereas the right environment is basically everything from content management, everything that is needed to actually run the IoT platform. And as you can see, there is a web front end, so people can use this environment using a web browser. There are different mobile apps, so they can use it. You can use those on Android, on iOS, on tablets. And the most important part is the little thing on the right side, IoT devices. This platform that we are running here is designed to run millions, like 20, 100 million, even more IoT devices. So most of our clients are not even people, it is just devices. And these devices need to talk to this environment. And they need to talk to it in an efficient way. It needs to work in a very reliable fashion so that you can actually, if you are in India and you have this device, you don't want to connect to a server in Germany. You want to have AP Southeast, for example. Or if you are in Sydney, you want to use Amazon there. Or in America, and you always want to have the fastest possible communication between the devices and the infrastructure. Also, I mean, this whole thing is completely interactive. If you do something on the web front end, it will be reflected on the IoT device. But the same thing works also the other way around. So you can actually go into the IoT device, do stuff there, and it will be reflected on the web interface or on your app. And everything works in real time. So just a few numbers. At the moment, we have in the public cloud environment 68 components in 6 environments in 4 regions. Altogether, 1,632 running components. That doesn't mean this is the definitive number of containers. This is basically just the minimal environment that is needed just to keep the whole global platform scalable, because this is actually what millions of devices actually use. In the private cloud infrastructure, things are a little bit simpler. There are just 32 components, 6 environments again. These environments is all like testing environment, automated integration environment, automated staging environment. And there, I mean, we are talking about a big company here. Everything is very political and everything has to be seen by many eyes before things get approved. So This stuff is continuously running, and they don't even care that these extra staging environments cost money. They want them, they have the benefit, and they are happy with this. So, and yeah, almost everything runs in Docker containers. We do have a few exemptions from that because we also are using a few components like SAP Hybris, for example. And these guys don't like us running their Hybris deployment in a container because then they are saying, no, you don't get support. But we are fine with that because the same approach, I mean, I just demonstrated this or I just showed you how to use it, do it in Chorus. But the same thing works in any single systemd supported operating system. So you can use CentOS, you can use Debian, you can use whatever you choose. So, things we learned, the really important things. Chef, Puppet, Ansible, you just don't need that stuff anymore. If you use Terraform the right way, if you use the modules and you use the templates, there's just no need for those. You can generate all your configuration files on demand. Just as a side note, I haven't mentioned this in the slides here, but the same approach works for Docker containers. So you can inject your configuration in form of an environment variable into a container. You have a simple run script that generates the configuration file. And when the container then, when the service then starts, it has the configuration already completely isolated inside of the Docker container. However, we can also generate that configuration in the build process. So we can even say, okay, we have a Docker image specific for an environment and have it versioned, properly versioned for every single environment, because every configuration change should be a deployment. If you do this stuff at runtime, you change a variable at runtime, that usually causes more trouble than it solves. Also, this gives you the ability to have instant rollbacks. You can always go back and use the previous version or skip a version, however you like it. And it's not even an extra tool that you need. Terraform provides that stuff out of the box. Think about Terraform and the modules like you would think about Makefile, where you have dependencies. And Terraform is smart enough to see which dependencies have been modified and which dependencies need to be changed. If you use CoreOS, this works pretty much everywhere. This works on bare metal hardware. You can install it using PXE over the network. You can use it on disk. You can use it with most of the cloud providers. So it works with Azure, DigitalOcean, Google Container Engine, Rackspace. I mean, you can read this yourself. But it works pretty much everywhere. And just for the kick of it, I also tried this using Hybrid OS on my Raspberry Pi. Now I know what I forgot. I actually wanted to take this little Raspberry Pi with me on the stage because, like I said, it just works and it is really simple. Hybrid OS is just like CoreOS. It just is built for ARM, provides you with a kernel, with systemd and Docker, and all you need to do is just provision your resources onto it. So theoretically, this also will work with the chip computer. You probably heard about this. It costs $9. It's really small, and if you order this in high quantities, it gets even cheaper. And now think about building the next IoT infrastructure. You have a small computer which costs almost nothing, which is totally easy to manage and maintain. You can get your software on this thing using Terraform and Docker in a really easy fashion. And you can build the next IoT product in a matter of minutes, because most of these modules are out there. You just need to use them. Just as a side note, I talked about this earlier, we are not using the Git repositories and the modules. We are actually building a dedicated Terraform module that has all those modules built in, and we use Terraform Get in there to fetch all the modules up front and bundle this into Terraform. Also has the advantage, all our ops guys use the same Terraform image. They don't have to install Terraform locally. The only thing that you have to have on your machine to work with this is Docker. Everything, every single process that we are building, whether that is cron jobs, whether that is service containers, whether that is deployment, automated testing, everything runs in a dedicated container. And that one, of course, is completely versioned. You have a complete build history, and it is just easy to handle. Another thing, if you work with a distributed team, think about the state management. For us, and we are a pretty big company, we have 4 offices in the world. We are in Germany, in Netherlands, in Spain, and in Cochin, just around the corner, where we actually have our biggest ops team. An S3 bucket is sufficient. You don't need to buy into the Atlas cloud stuff. You don't need to use that stuff. A simple S3 bucket, have a Terraform state file that is named as the environment is sufficient. You can work with as many people as you like. So that stuff is actually almost free. I mean, it doesn't cost anything. So, yeah, thanks for your time. And if you have questions, shoot. Wait, there's a microphone, I think.
Hey, over here.
Hi.
Thanks for your talk on Terraform.
Yes.
I've been using CloudFormation now for a couple of years, and one of the problems I've noticed with CloudFormation is the somewhat unreliable states you can get when you try to update a larger stack, and if it fails, then you get into a state where you can no longer update that stack.
Yeah.
From what I saw in your talk, the scale of your infrastructure is much larger than mine. And I'm curious what your experience is when things don't go according to plan with Terraform updates and rollbacks and things like that, less happy path scenarios, and how that maybe compares to CloudFormation in your experience.
First and foremost, I mean, just to understand what CloudFormation and Terraform is doing is pretty much the same thing. I mean, CloudFormation is just a service that is running at AWS that talks to the same APIs that Terraform is talking to. So if you provision an EC2 node, it's pretty much the same thing that CloudFormation is doing. The main problem that we actually had for a long time, because we use CloudFormation as well, and we ran into exactly the same issues that you noticed, that you mentioned, is you have to have a reliable way to manage your state between the environments. And Amazon basically promises you that this stuff will just work if you upload your JSON file to CloudFormation. But now think about a complex environment like this. How big would the CloudFormation script be? I mean, if you really would render out all the build plan that is being generated by Terraform, and Terraform in the end just produces JSON and communicates that to the APIs. We are talking about, I think, 70,000, 80,000 lines of just JSON statements or JSON configuration that is applied at the services. So the problem is, for us, it starts really at the management of that file, because as soon as you want to deploy it, you already have to have it committed to somewhere. And then if you have a team with like 60, 70 people that are working with that, there's always that one guy that forgets to do a git pull. And then it will break your deployment. And this is basically what Terraform ensures will never happen. So pretty much all the problems that we had with CloudFormation, they are just not there.
Okay, then a follow-up then.
Yeah.
I'm not sure if you mentioned it in your talk, but do you use Terraform to provision infrastructure for stateful things, say like a database or things like that? We actually opted or decided to stop using CloudFormation for some of those more stateful things because of some of the dangers with CloudFormation. I'm curious if you made a similar trade-off or design decision in your system.
Yeah. So to give you an example, this environment has a big RDS database in there. And RDS in the end is MySQL. So Terraform actually has a MySQL provisioner that you can use to provision databases. However, the problem is we have long-running environments, and these environments get updates, so we get schema changes. So we basically opted to use neither. We basically use Flyway. I don't know if you have heard about this. This is a tool to basically manage SQL databases, and you basically can manage migrations, so from one schema change to another, and you can even do rollbacks. And it's really simple. It's written in Java, flyway.org, I think. It's really nice. And we just execute that from Terraform, and it works flawlessly. We also use DynamoDB, but that we provision directly using Terraform because the Terraform support there is awesome. And I mean, DynamoDB is just a simple hash table in the end, so there's not so much complicated stuff as what you could do with a MySQL database or other databases.
Cool, thank you.
Yeah, there was a question here. Hi. Can you get the mic? Okay, then you.
Hi, in one of your slides you had listed Telegraph as a tool that you're using. Could you maybe throw some light on the use case for Telegraph there?
Yes. So we are not just producing logs on these machines, we are actually producing quite a lot of metrics. And many of our custom services that we are running on these environments, they produce metrics as well. And we need a way to transport these metrics in a reliable way for, let's say, from Sydney to Europe or to wherever we have our metric platform running. And Telegraph is really awesome in that way that it basically out of the box supports pretty much all the popular open source components, and it can read metrics, for example, of Apache, of MySQL, without any additional configuration. You just tell it, okay, use this, use that, and it runs in a Docker container. It's just linked against the container that is running on the same host. So it just makes the metric collection really, really easy, but it also provides you with a service port where you actually can just write your metrics into using Netcat or whatever you want to use. So it's just, this is one of the many small pieces that we're using. For example, log collection, we do in a similar fashion. We use FluentD for that. However, we use actually AMQP to transport the logs. So we have a RabbitMQ cluster, and that basically guarantees if we have high latency collections between, for example, Sydney or South America, and we want to transport the logs into our Elasticsearch. I mean, you could do it directly using Logstash and using unreliable protocols and UDP and whatever, but for us it's not really acceptable to lose one metric or to lose one log file. So we always use consistent, reliable protocols for the transport. So the only point where we use stuff like UDP, what you would use for metrics in general, is always just localhost connections. This is basically where Telegraph jumps in for the metric collection and FluentD for the logs.
Thank you.
Wait, there is...
So my question is, are you also using Vault along with Terraform?
Yes, yes. The thing is, Terraform actually currently has no Vault provider. We are using the same workaround that we use with building the Docker images. We have a null resource and a local exec, which we then use to use the Vault client to provision credentials if we want to provision a new service. But usually it's the other way around because credentials are created at runtime. So we can use stuff like the key rotation and credential rotation. We don't really have to worry about that. It's actually a task that even the ops guys have nothing to do with it. And the only difficult problem there is setting up the initial Vault cluster, which is exactly the same setup that we are using for console because it's the same problem. It's a rough cluster and you need consensus, a quorum, and but it's really simple to do, and it's just one Docker image.
Thanks. Thanks.
Hi, my name is Tapan. So, thanks for this Terraform thing. So, this is pretty new to me, and so what I want is that whether we can provision the bare metal like the crowbar or the racking does, can be integrated to Terraform to make it work.
Like I said in this one slide, it depends on the way you build your stuff. And we just wanted to have a way where we have one way of configuring services, deploying services, and managing services. And we basically just have the requirement, we need Docker and we need systemd. So you need an operating system that has that. As long as you can boot your physical infrastructure with something that provides it to you. So in this example, Hybrid OS for ARM devices or Core OS for Intel hardware, you can boot that stuff using PXE or IPXE. For many companies, you can even provide them with images and they just boot those images for you. So Terraform supports that and it has the providers and provisioners for that.
Yeah, thank you.
Yeah.
Just want to check on one thing. We are talking about IoT devices, right? So do you support across like multiple regions? Suppose I have a device in India here. So for me, the AWS region would be, nearest one would be Mumbai.
Yeah.
And if I move to some other region, maybe Singapore or something. So how does that shift happen? Or do you support, how do you manage that?
At the moment, there is no as the way these IoT devices work that we have, they're basically using a synchronizing mechanism. So the user basically has to push a button on the device, please start communicating now, and it will then start the synchronization process and will do that stuff for you. So moving between regions is not really a problem because we don't have persistent connections per se. I mean, if you think about the Amazon Echo, for example, this Alexa voice box, it basically doesn't communicate anything as long as you are not giving it the wake word that you say like Echo or Alexa, do this and that, and only then it starts talking to something in the cloud. So by default, these devices don't do much traffic, but as soon as people are using that, and the devices that we are talking about are typical household appliances, so you have the typical phases in the evenings in the local time zones where people are using those, these devices don't really move around. However, you could use the same approach, of course, with portable devices. So if you have IoT device that people could carry around in their pocket and they could travel from one country to another, I mean, you can always go back to geo-IP and just do the routing that way. And since all the environments that I've shown are configured exactly in the same way, I mean, they have a different prefix for DNS and stuff, but all that stuff is completely automatically managed, and it is not an issue. So at least not for us. I don't know if there is a scenario where it might be an issue, but I haven't seen any yet.
Okay, thank you.
Anybody else? Okay, then thanks for your time, and I look forward to see the rest of the day and maybe talk with a few of you guys in the afternoon. One thing that I have mentioned in this talk is, of course, Consul. We are currently looking into Fabio for zero configuration load balancing. So if you guys are interested in talking about that, or if you are interested in talking about Terraform in general, I will be available in the open space. And most of my colleagues are sitting here, at least a few of them, and they probably like to talk with you as well if you have questions. Yeah, thanks.
Thanks, Robin. It's a sin for mobile phones to ring in